At the end of this video, you will be able to build a code that removes the background of any image just like the one that you're seeing on now. Now, we will be using the Gaussian mixture model from scikit-learn and we'll be explaining what it does as we progress along. We will need to import the image itself first, and this is available from scikit-learn datasets. You don't have to download it from anywhere else. So to import this, you just type in from sklearn.datasets, import load sample image, and then run this. Now that is done, we want to load in the image, and I'm just going to call this China, and we just use the load sample image function that we just imported. Image, and inside this, you will have two images. One is the flower.jpg, and the other one is china.jpg, which is what we're going to use for this video. Let's do that. And before plotting this, I want to actually normalize the pixel values. First, you might be familiar that all of the pixel inside of the images are going to be in the RGB format where the values range from 0 to 255. I don't want that. I just want the values to be between 0 and 1. So to normalize this, I'm going to type in China by 255, just like that. This is normalized now. Now, in order for us to plot this, we will need map.lib. So let's just import that. Import map.lib, pyplot, it's plt underscore once again. And then over here, you just type in plt.fixsize to be 12,4, just like that. And then you also want to create a subplot because we're going to plot 3 images in the same subplot. So let's just create that subplot. I just want 1 row, 3 columns for 3 images. And then the first column will be used for the first subplot. plt.imshow function is what I'm going to use. And inside this, I will mention the data like that. And I will also set the axis off. That and just type in plt.show with this code. Now we see that we get an image. This is the image that we will be working on. Now, as said earlier, I will be using the Gaussian mixture algorithm from scikit-learn. So what this does is clustering the images based upon some factors. For example, when you look at the color for the building that we're seeing here, the object itself, when it's compared to the sky, it's relatively the same. So maybe it will create a cluster for the sky where all of the pixel values within the sky are clustered together, and then the building is actually clustered together, and same goes for the tree. This is just an assumption. There are many different factors that works on this. So let's just import the Gaussian mixture. This will be available in scikit-learn.mixture, like that, and then we want to import mixture. Now we'll also need numpy. I will explain why I'm going to use it. Let me just import that, numpy as np. Let's just run this, and we have that. And let me just create the model straight away. Gaussian mixture model will be just call the instance that we just imported, Gaussian mixture, and then inside this you want to mention 2 parameters. One is the n components, that is the number of components or the number of clusters that you want to create within the image that you're providing. So for here, I just need 2 clusters, maybe trying to segment out the object itself from the background. So we only need 2 clusters. You can have as many clusters as you want, but then it's just going to be simpler for us to plot. N components will be just 2. And then there's one more parameter. This is kind of optional. I'm just going to do so. Random state will be 42. This is for ensuring the reproducibility. You already have to understand this. Now, before we provide this data to the model, we again have to do a bit of pre-processing. And for this, first, I would like to show you the shape of our data, data.shape. Let's just run this. You get a 3-dimensional space over here. We see the 427, which is indicating the height, and this is the width. But then here we get the number of channels, that is the number of RGB values and everything. We just need 2 dimensions if we're going to provide that to the model, because the model understands 2 dimensions better than 3. So what we had to do is to convert this to 2-dimensional. First, we have to get the height, width, and then the channels by using this data.shape. And then what we can do is create a reshaped data. And then inside this, you just type in data.reshape. You mention width into height as one of the dimensions, and the other one will be just channels, just like that. Now that this is being done, but you just directly provide this to the model by using the model.fit function, gmm.fit. You want to provide the data that you're actually working with. So inside this, I'm just going to mention the reshaped data. And then I'm just going to directly run this. You're not going to see anything until we predict something, but then let's just wait for the program to train. Okay, so now the training is done. And what I'm going to do is just type in gmm.predict and show you the results. Just pass in the same data set once again, data. So we see that we get a 1-dimensional array where there's just 2 values, 0 and 1. And this is because we only have 2 components over here. When we mention 3, then there's going to be numbers between 0, 1, and 2. So what this indicates is we have 2 clusters over here, and one is named as 0. Let's say that the sky cluster is named as 0, and then all of the rest is just named as 1. In fact, it's going to be much better when we plot this. So what I'm going to do here, let's just create a labels variable, and then put this over here. But what we can do is you just want to create a segmented image variable. Let me just first type it out. You will understand when I plot it, which will be we want to reshape this prediction by using the reshape function to do dimensions, because we're actually going to plot this in matplotlib, which requires 2 dimensions, and that is the width and the height. So height, the width, just like that. And we want to have these two. Let's just put that and paste it over here. And the second subplot for this is going to be the segmented image. So let's just type that. Actually, let me just copy paste this, copy and paste over here. Over here, just want to change this to segmented image, and then mention a color map to be, let's say, plasma for better visualization, like that. And you want to stay and change this to the second subplot, but it's the second column. Now when you run this, actually, we don't need the BLTL show function over here. Got this like that. So run this. By the way, if you've been getting value out of this video, consider subscribing. Now we get the segmented image just like in this form. As I said, there is 2 clusters over here. One is the sky and the other is the object along with the trees. So let's say that since we looked at the labels, let's just run that once again. We get an array of values between 0 and 1. Not between 0 and 1, it's just classified as 0 and 1. Now over here, let's just assume that the sky cluster is labeled 0 and then all of the object is labeled as 1. So what we want to do here is just segment this first cluster, that is the cluster that is labeled as 1, according to our assumption. We just want to take that out and then retrieve the original compositions, but then we want to fill out the background with black color. So let's just do that by first creating an object mask. Let me just show you what I mean. Object mask is a variable I'm going to create, and then you first want to mention the condition. Let's just type in labels equal to 1. What this means is we're checking for this condition where labels are actually equal to 1, and then I'm also going to reshape this to 3 dimensions because we initially started off with 3 dimensions. So what I need to do is just type in height, width, and then 1. Now why we have this as 3 dimensions, because this is where we started off. We just converted this to 2 dimensions when we provided this to a model. So when we were taking it out and trying to plot, we just want this to be in 3 dimensions. So when I run this, actually I've got the filters out. So you clearly see that you're going to get a boolean, whether it's false or true, but then the difference here is you get that in 3 dimensions like this, and that is what we want because we're going to plot the image just like we wanted to. But what we could do is then again create an isolated object. Here we mentioned that the labels is 1, so we assumed that this cluster, the yellow cluster, as our object itself. So we can use the np.where function, and then inside this you can just mention the first condition that we created, the object mask. This itself is a condition which is just reshaped into 3 dimensions. That's fine. Now we get the conditions, and if the condition is true, then we want the original data, the color proposition and the values and the pixel length and everything exactly to be the same for the cluster that is actually true. And whereas if it goes to false, then you just want to return 0. So what this np.where function does is it takes a condition, and if it's true, then it returns the x value, and if it's false, it returns the y value. Now, by returning 0, we get a 3-dimensional 0, that is 0, 0, 0. Then this indicates black in the RGB format, which is actually what we want. So that's about it. We get this isolation object. Let's just cut this and paste it onto our main code like that. And then we want to plot this onto our third subplot. Just copy this, paste it over here, demonstrate 3. And inside this, you want to use the imshow function and then type in isolated image. On this, it's isolated object, like that. Let's just run this, and there you go. Our assumption was correct. We turned this to be the first label, and then we segmented that out. We took that out by filling the background with black color using the np.where function. For example, if you want just the sky, we just take out the sky cluster, whereas when you want to fill the other cluster with black color, you can also do that. All you have to do is mention this labels to be 0, and this time you're checking for the condition for the first cluster where the blue color, the sky color, is labeled as 0, and our assumption was correct. So when you run this, you kind of see that you're going to get the sky outside, whereas the object has been blacked out. Now, that's all we did over here. We just created an object mask to take out the specific cluster that we wanted, which was predicted from the model, and then you retrieve the original data propositions, whereas when you fill the other cluster with black color. Now, there are many such algorithms in scikit-learn, just like the Gaussian mixture, and I'm just going to link one of those right now. I recommend you to watch next.